Right, welcome to today's live stream. It's going to be looking at the properties of shapes, starting off with area and volumes and looking at scale factors. So I'm going to give you a couple of minutes to have a go at this first question. Off you go. Right, so here's our first question, and it's a volume and area scale factor problem. So we've got solid A, and let me just grab a pen, and it's not giving me a pen, just give me a second. Right, there we go, got a pen. Sorry about that. So we've got solid A and we've got solid B. And we know the ratio of the area of solid A to the area of solid B is in 16 to 36. So therefore, if this is 16 to 36, we're going to times by 36 over 16 to get from this area to this area. So that's our area scale factor. Our area scale factor is equal to 36 over 16. And we can square root that. Sorry, I'm just going to move that square root sign. We can square root that to find our length scale factor, which gives us 6 over 4, which equals 3 over 2. So our volume scale factor will equal 3 over 2 all cubed, which just gives you 27 over 8. So to find the volume of solid B, will equal our volume scale factor, 27 over 8, times by 2, 4, 3, 2. Which is very doable without a calculator. You can see I've done it already. Okay, you could just divide this by, cancel this down with the 8, so factors are 2, and then times at the end by 27. To save time in this stream, I'm going to do 27 divided by 8, then times by 2, 4, 3, 2, to get 8208. 8208. On the right, so you can see it, 8208 centimeters cubed. Right, next question, here we go. Let's give you another 2 minutes to try and do this one. Right, looking at this one, we got solid X and solid Y, and we're now looking at the volumes of these two. So volume of X to volume of Y, and we know that the scale factor here is going to be 125 divided by 8. So therefore, if the volume scale factor equals 125 over 8, then the length scale factor will equal the cube root of that, which just gives you 5 over 2. So our area scale factor will just equal that squared, so it'll be 25 over 4. Now we know that the surface area of volume of solid Y is 475, and we're going to times by 25 over 4 to get from the area of X to that. So to go backwards, we're going to divide by 25 over 4. So grab our calculator and we do 475 divided by 25 divided by 4, and we get 76 as our answer. Right, moving on to the next question. I'm going to give you just a couple of minutes to have a go at this one here. Right, here we go. So we've got the height of this is 13, the height of this is h, and we know that it takes 96% more paint. Now the key part of this is the more. Okay, it's 96% more paint. So that means that this one's going to have 196% of paint compared to the 100% of paint of this. So that means our scale factor, and it's going to be area scale factor because paint goes on the surface area, is going to equal 1.96 when you can work out what do I times this by to get this. So if the area scale factor equals 1.96, then the length scale factor will equal that square rooted. And I don't know if you spotted that 1.96 is actually the equivalent of 196, which is equivalent of what? A 14 squared. So therefore, actually the length scale factor is 1.4 when you square root that. So just a quick way of showing you how to do the mental arithmetic there. So therefore, we want to times the 13 by 1.4 to get h. So h equals 13 times 1.4. You could think of that as 13 times 14 to get 182, move the decimal place back 1 to get 18.2 centimetres. Right, let's look at our next question, which is a little spheres problem. Here we go. I'm going to give you 3 minutes to do the whole of this one. Okay, I probably just took a little bit more fault, but it's still all about volume and area scale factors. So, grab myself a pen. So we got the sphere has a mass of 750 kilograms melted to make smaller spheres, radius 1/5 the original. So the length scale factor is now equal to 1/5 of the original, and so therefore the volume scale factor will be 1/5 cubed of the original. So it's going to be 1/125th. So therefore, if each volume is 125th, therefore the mass will be that as well. So the mass of the small one will equal 1/125 times 750, which equals 6 kg. The surface area is 10,000 centimeters squared. So we now need to find the area scale factor for each one. So the area scale factor, if the length scale factor is 1/5, is going to be 1/25. That's 1/5 squared. Okay, 1/5 all squared. So therefore, we're going to times the area of one small sphere is going to equal 10,000 times 1/25. And then, because we know there was 125 of these smaller spheres because the volume scale factor is 1 over 125. Therefore, we're going to actually times that answer by 125, and those are going to cancel out to be just timesing by 5. So my answer is going to be 50,000 centimeters squared. So let me just take you through that again. The area scale factor is 125, so that gives me the area of one of them. So total area, that's the area of one of them. I don't need to work it out because I realised I was going to end up times by 125 because I have 125 of these small volumes, because we know that the volume scale factor is 1 over 125. So times by 125, and then that cancels to just timesing by 5, which is an easy thing to do. Right, last question for today. A volume of frustum problem. Let's give you 3 minutes to think about this one. Right, I'm just going to put in here the link to the MyMaths. If you want to go away and practice some more of these, they'll give you different numbers so you can test whether you understand the questions. If you found these difficult first going through and you didn't get any of these right first time, I highly recommend you have another go using the MyMaths. Or if you haven't got access to MyMaths, then just rub out my download my OneNote notebook. The link is in the YouTube channel, and then just rub out my answers and have another go. Right, what we're going to do here is we've got this height, this cone 3h, and the trick to this is to find the volume of this cone. Now this one must obviously have a height of h. So the scale factor of enlargement from big cone to the small cone is going to be 1/3 from 3h to h. So we know, therefore, if the length scale factor equals 1/3, then the volume scale factor must equal 1/27. Now we're told it's part of a cone height 3h and volume 270. So therefore, this small cone, okay, the volume of small cone with height h is going to equal 1/3 cubed, or 1/27, times by 270, which equals 10. So therefore, the volume of the cup will equal that 270 minus the small cone, 10, which gives you 260 centimeters cubed. Okay, so remember the trick for this is to find the scale factor enlargement from big cone to small cone, work out the volume of the small cone, take it away from the large volume original, and then you can find the volume of the cup. What I'm going to do in here is put a link also to my maths. So we do that. It will allow me to put a link in for this sheet, and I'll paste that onto every single page as well. And then you can go away and do more revision on this. Tomorrow there'll be the 8 to 9 session of this at 4:30. Look forward to seeing some of you trying to stretch yourselves on that one. Good.